All right, so in this section 10-2, we're looking at parametric equations part 2. And so last time what we did was we had a set of parametric equations, and we took those and wrote it in rectangular form by eliminating the parameter and just writing an equation for y in terms of x. Okay, this time we're kind of doing it backwards. This time we're starting with the polar equation, or the y in terms of x, and using a parameter we're going to write the parametric equations. So last time we started with the parametric equations and wrote the rectangular equation. This time we're starting with the rectangular equation and writing the parametric equation. So let's take a look at how to do that. All right, so we want to find a set of parametric equations to represent the graph of y equals 1 minus x squared using the parameters, first of all, t equals x, and then next, t equals 1 minus x. So two separate problems here. So they've given us a parameter, and so how do we do that? So the first thing that we want to do is take the parameter and solve it for x, and that's my x parametric equation. Well, in this one it's really easy because it's already x equals t. So that is your parametric equation for x, right? Now, how do we take that and make a parametric equation for y? Well, if x equals t, then I can take the x out, put t in its place, and that's what we've done here. Y equals 1 minus t squared, and that's your parametric equation for y. Now, this one was pretty simple because x equals t. So all I had to do was take the x out and put t in its place, and then I had my equation, right? So these are my two. Okay, what about the other one though? So what about my parameter is t equals to 1 minus x? Well, first step, rearrange this and solve it for x, and then that gives you your x parametric equation. So move the x over here, move the t over here, we get x equals to 1 minus t. That's the x parametric equation. Now, how do we get the y parametric equation? Well, I need to take 1 minus t, that's what x is equal to, and plug it in here, right? So I need to take 1, so that would be 1 minus t closed squared, right? So that goes in for x. And so when you simplify that by squaring this out and taking the minus there, so you'll be ending up with 2t minus t squared. All right? And so that is the parametric equation for y. And then the graphs, of course, are there as well. Okay, so let's practice some more of those problems, see what they look like. Okay, so in this one, we want to use each parameter to write parametric equations that can represent y equals x squared minus 4. Okay, so there's my rectangular equation. I have a parameter now, 3 different parameters that I'm going to use to write parametric equations for this rectangular equation. So the first one I have is t equals x. Okay, so I need to use that parameter to write parametric equation for x and y. Well, x is easy. If t equals x, then x equals t. That's the parametric equation for x. And of course, when they're equal to each other, it's also very, very easy to get the y parametric equation, because all I will have to do now is change the x to a t. And that becomes y equals t squared minus 4. So anytime t equals x, it's very easy to generate your parametric equations, right? Now, what about if t is equal to 4x plus 1? A little more work. I need to solve this one for x. That'll be my x parametric equation. And so by doing that, let's say that 4x is equal to t minus 1. So I'll move that 1 over there, t minus 1. Now I'm ready to divide by 4, and I'll get x is equal to t minus 1 over 4. That is the x parametric equation. How do we get the y parametric equation? I need to take t minus 1 over 4 and shove it into x. So that becomes y equals, and that's going to be t minus 1 over 4 squared minus 4. All right. And so now I'm going to have to take this top part here and square it out. So I need t minus 1 squared. And so t times t is t squared, right? And t minus 1, that's negative 2t. And then negative 1 times negative 1 is positive 1. And of course we've got a fraction here. 4 times 4 is 16. All right? And that's still going to be minus. And I'm actually going to go ahead and make that a common denominator by multiplying the top and the bottom by 4. And so that would be, what, 64 over 4. Okay? And in order to finish it, we got one more step. And so that is going to be now, and I'm going to actually divide the 16 into all of these terms. So that's going to be 1 over 16 t squared minus 1 over 8 t. I'll write that a little better. Okay, 1 over 8t. I don't like how that came out. Try to write that again. 1 over 8t, right? And then minus, so this is 1/16, right? Minus 64, and I put 4, that's actually 16. Need to change that. So 1 over 16 minus 64 over 16 is minus 63 over 16. And that is the simplified form of the parametric equation for y. So these are your two parametric equations, one for x and one for y for this parameter. All right. One more to rewrite. So let's say this time t is equal to 1 minus x over 4. Well, if I solve this for x, I'll have the x parametric equation. I'll go ahead and move this x over here, move this t over here, and we'll get x over 4 equals to 1 minus t. And I'm ready to multiply by 4. So x is equal to 4 minus 4t. And you can leave it just like that. The t term does not have to come first in this case. And so we need to write out the y parametric equation. And so I'll sub x for this, and it becomes y equals x minus 4t close squared minus 4. So that'll be y is equal to, let's see, what do we get here? Square that out, get 16. And in the middle, that'll be minus 32t, right? 4 times 4 is 16, and 16 minus 16, negative 32. And then here, that'll end up being positive, looks like 16t squared. 16t squared. And I have a minus 4 out here that I will finish it up with. And so we can write this as 16t squared minus 32t, and then that'd be plus 12. All right, and so that is how you take the polar equation and then write parametric equations out of it using a parameter. All right.